Hello everyone, welcome to the video solution for physics. This is Edexcel IAL Unit 3, January 2019. So let's start. Question number 1. Which of the following is an SI based quantity? A typical question regarding quantities in the unit. You need to find the SI base quantity. Now if you see the choices, charge and the coulombs, they are not SI base, they are SI derived quantities in the unit. And second and the time, both are base, SI base, but they are asking you the quantity, not the unit. So second is SI base units, so it's not the choice. So the choice is time, and that means D. Time is SI base quantity, so your option is D. Question number 2. What is the reading on the vernier scale? So this is a vernier scale. The top one is main scale reading, read in millimeter. The lower one is a vernier scale. And the method of reading the vernier scale reading is, first of all, you need to see which line of the main scale is close to the zero of the vernier. And in this case, if you see, this is 10, 11, 12, 13, 14, and 15 and 16. So 16 millimeter on the main scale close to zero, or before just zero. So 16 millimeter is your main scale reading. And now after that, you need to see which line of the vernier scale is best coinciding with any of the main scale reading. If you see, this is line number 1 of a vernier scale. It is not coinciding. 2, it is not coinciding here. But if you see line number 3, again it's not. Yes, line number 4. If you see, line number 4 is best coinciding with the main scale. So that means this is line number 4 means 0.4. So you add these two numbers and you say that 16.4 millimeter is your vernier scale reading. So your option is B. Question number 3. 4 and 5 refer to an experiment to determine the acceleration of free fall by measuring the time taken for a tennis ball to fall through a given height. The height is measured with a measuring tape. The times recorded are 0.96, 0.98, 0.89, and 0.99. Which is the best statement of the time the ball took to fall? So you are given a data set for measured time, and you need to find the mean value. Again, a typical question of finding mean from a data set, and usually they want to check your concept of anomalous reading. So see if you can detect any anomalous reading in the data set. So 0.96, 0.98, 0.89, and 0.99. Clearly this 0.89 is your anomalous reading, so you need to discard this value from the data set, and you need to find mean value of these three numbers. And once you find the mean value of 0.96 plus 0.98 plus 0.99 divided by 3, your calculator is going to give you 0.9766, and you might get confused looking at 0.976 with the option C, but you need to be careful about choice of the answer, because your data set given in 2 significant figures, or you can say that 2 decimal place. So you need to give your answer into 2 decimal place. So don't think that you can give answer in 0.976, which is 3 significant figures, or 3 decimal place. So if you round this number off, and you can clearly see that after rounding off you have 0.98. So your option is D. Again, question number 4, the same experiment. Which of the following quantities is also required in the calculation? Initial velocity of the ball, mass of the ball, diameter of the ball, density of the ball. Okay, so of course you see that this is the experiment in which you are dropping, or you are letting a ball to fall from some height, and it is falling. And of course in this experiment, if you remember, we use Seurat equation. So we need velocities, we need acceleration, time, and the distance traveled, or height fallen. In this case, we don't need mass, diameter, and density. Of course, we need initial velocity of the ball. So option is A. Question number 5. Which of the following is not possible source of error in the experiment? So reaction time, of course we are measuring time, so it is possible source of error. Zero error in a measuring tape. Parallax error, because we need to measure the height from meter rule, so we might have a parallax error. All the 3 are possible sources of error. Ball not reaching the terminal velocity, there is nothing to do with the terminal velocity in this experiment, so our option is D. D is not a possible source of error. Question number 6. A student investigates how the current varies with potential difference for a filament lamp. Draw a circuit diagram for this investigation. So we need to study the relation of current with the potential difference of the filament lamp, and we need to draw the circuit diagram. A typical circuit diagram, because we need to investigate how current varies with the potential difference. That means we need to change the potential difference first. So this is our independent variable, and the current will be dependent variable. This is the key point. That means we need to use a potential divider circuit in this case. And the circuit diagram is, first of all, you need to connect bulb. So how many components we will be using in this experiment? We will be using bulb. This is the symbol for bulb. We will be using a potential divider or a rheostat, and if you see, this is the symbol for rheostat. So 1, 2, and we will be using voltmeter and ampere meter. It's the 4th one is ampere meter, and then the 5th one we will be using power supply. So if you need to understand this the circuit diagram, the easiest way of understanding circuit diagram is you need to ignore, in this special circuit, you need to ignore your voltmeter initially and the rheostat, and rest of the component, like 3 component, bulb, ampere meter, and the battery, you are going to connect in series or a closed loop. So you will have to join bulb with the ampere meter, and then ampere meter is going to connect with the power supply, like that, and then power supply goes to the bulb, and then you need to connect the potential divider or rheostat parallel to the bulb. So that's how you can connect. This is your and then the slider is going to connect with the voltmeter, and then voltmeter goes to, that's how you draw the circuit diagram of this experiment. So you can move the slider or the rheostat, changing the voltage due to which the current is going to change. This is a circuit diagram. The student uses digital meters. The manufacturer states that these meters are more accurate than analog meters. State one other advantage of using digital meter rather than analog meter. Clearly, digital meter is easy to read than analog meter, because in analog meter we have a needles and we have a chance of parallax error. So in digital meter we don't have a chance of parallax error. So you can say that there will be no parallax error in a digital meter. Part C. The student checks for zero errors before taking reading. Explain another experimental technique the student should use in order to make investigation as accurate as possible. Whenever you are asked to find the any technique to improve your reading, and they are not talking about any technique of repeating reading, so this is the way that time that you can say that the student should repeat the reading and use mean value to get the more accurate value or to reduce random error. So you can say that the student should repeat the readings and use mean value. A student is asked to determine the density of a glass as accurately as possible. He has been provided with a box of 10 glass microscope slides. The approximate size of the slides is given on the box. Length 76 centimeter, width 26 millimeter, and thickness 0.9 millimeter. Write a plan for this experiment. You should include all these things. So state the quantities to be measured. Remember, what do we need to do? We need to find the density of a glass slide, and density is mass over volume. So mass we can measure from the weighing balance, and volume we need to measure from length, width, and thickness, T you can say. So we need some other devices. So state the quantities to be measured. So we are going to measure the length, width, and thickness, and the mass of the slides. So that's how you can write. List the apparatus required. Of course, for length and width, we can use meter ruler. Thickness, because it's a very small measurement, so we can use micrometer screw gauge. And the mass, we can use weighing balance, a mass balance, for calculating the mass. For two of the quantities listed in A, explain your choice of measuring instrument. Of course, these are typical question in every old specification paper. So choice of the measuring instrument, if you are using meter ruler like this, so meter ruler we are using because the precision or resolution of the instrument is 0.1 centimeter or 1 millimeter, quite appropriate to measure the length and the width. And for micrometer screw gauge, the resolution or precision is 0.001 centimeter, quite appropriate for thickness. Part D. Comments on whether repeat readings are appropriate. Yes, indeed, repeat readings are appropriate. You can say that the repeat reading is good to remove any random error, or maybe you can detect any anomalous result when you repeat the reading. So that's how you can write. E. suggest how to make measurement of thickness as accurate as possible. Of course, to get accurate thickness, you will have to measure the thickness from different places, and you can use mean value to reduce the uncertainty or percentage uncertainty in your measurement. Explain how the measurements made will be used to determine the density. You will multiply length, width, and thickness to get volume, and then rho is equal to mass over volume. So you can say that you can measure the length. Volume is length into width into thickness, and then density can be found using mass over volume. State the main sources of uncertainty and systematic error. Zero error in a micrometer screw gauge, and slides are very small so that there might be variation in thickness. Comments on safety. There is one safety precaution we should take, that because we are using glass slides or slides made of glass and which are very small and sharp edges, so we must handle with these slides with care. Question number 8. A student determined the speed v of sound using standing waves in an air column. A diagram of apparatus is shown. So this is tuning fork, air column reservoir. Okay, meter rule 100 and 0, so 1 meter rod. The student held a vibrating tuning fork above the air column and moved the reservoir up and down to change the length L of the air column. She determined the shortest length at which the sound of maximum loudness was heard. This happened when the standing wave this happens when the standing wave is formed in the air column. She recorded the length L as shown in the diagram using the meter rule. She repeated this for a number of tuning forks, each marked with a different frequency F. Her results are shown in the table. Okay. Okay, so this is the result. Criticize these results. Again, a typical question. Given a table and the value, they are asking to criticizing the result. The very first is very few readings or quite less number of reading, only 1, 2, 3, 4, 5, 4 sets of reading, which is quite less reading. Again, and there are no equal interval between the readings of frequency. And if you see, the length is measured in consistent significant figures. So 3 significant figures, 2 SF, or 2 significant figures. So these are typical question, and these are typical marking scheme or answer for these types of question. B. A student used L to calculate the wavelength lambda of the standing waves. Okay, explain why the student calculated lambda as 4L. Okay, now if you see your diagram that is given, so you were given air column. If I draw the air column, something like this is the air column, and suppose till here you have water level. Okay, and then this is the air column or the standing waves formed like this. Oh, sorry, this there must be a node here. Okay, this is like this. So this is the standing wave is forming, and this length she's measuring as L. And you know that at open end we always have an antinode, and the closed end we always have node. So this is node formation, and from antinode to node the distance in terms of wavelength is lambda by 4. So you can say that the length measured is equal to lambda by 4. So lambda is equal to 4 times of L. C. Part 1. Show that the graph of lambda on the y-axis against 1 upon f on the x-axis should be a straight line through origin. Okay, so graph of lambda against 1 upon f. So you need to find a relation or equation between lambda and 1 upon f. So if you see that the relation between lambda wavelength and the frequency is v equal f lambda. This is a wave equation that we use because we are dealing here with sound waves. So velocity of sound waves is equal to f lambda, and in this experiment velocity remains constant throughout the experiment. So we take this advantage and we rearrange this equation as lambda is equal to v into 1 upon f, and clearly you can compare this equation with y equal mx. So you say that m is v, and this is the equation of a straight line passing through origin. That's why graph of lambda and 1 upon f is a straight line. So you can think that lambda on the x-axis, 1 upon f on the y-axis. So you must have a straight line passing through origin. Plot the graph of lambda on the y-axis against 1 upon f on the x-axis on the grid provided. Use the extra column in the table to show your process data. Now if you see your previous page, the data given in the table is this, and you were given only 3 columns. The 4th column is empty. So the reason is this column you need to, because we need to plot graph of lambda, which is this in meter, and 1 upon f, which is not given, but we are given f. So we need to find 1 upon f in the 4th column with the frequency is hertz minus 1. And you need to take 1 upon f of all these number, and you need to write these numbers here. And if you do that, if you do 1 upon 256, 1 upon 320, 1 upon 348, and 1 upon 512. If you do that, you have these 2 columns here, and we can process our data and we can plot the graph. So how do we do that? So this is the column that I took here. This is lambda, and this one is 1 upon f and hertz inverse. And if you do whatever I showed over there, so you can have 3.9 10 to the power minus 3, 3.1 in 10 to the power minus 3. So these are the values of 1 upon f. So you can plot the graph lambda on the y-axis and 1 upon f on the x-axis. This is your grid. This is lambda, and from 0.5 till 1.3 I am taking this 1.29 and 1 to 5 into 10 to the power minus 3. And if you plot the graph lambda against 1 upon f, so you have these 4 points, 1, 2, 3, 4, and then after that you need to plot a best fit line. And best fit line is a line that are passing through from maximum point, or all the points should be at equidistance from the line. So that's how you can see the line, best fit line. So that's how you do your question number 5. Use your graph to determine the value of the speed of sound. Remember, if you recall, what did we do in the previous question? We said that lambda is equal to v into 1 upon f, and we compared it with y equal mx, and m, which is the gradient in this equation, and m is equal to velocity. So if you have a graph of lambda and 1 upon f, then the gradient of the line will give you the velocity. That's how you need to find the velocity. So you just find the gradient of this line, and for the gradient of this line you need to choose a big triangle, as big as possible. That means you need to choose 2 different point on the line. Remember, on the line, not the point that you plotted. Don't choose those points that you plotted. You choose 2 different points on the line, and you draw a triangle like this. So you can see that here, like that, something like that, and you can choose any other point. Okay, and see, this is your triangle, and you need to find the coordinate of these points, and you can use the formula gradient is equal to y2 minus y1 divided by x2 minus x1 to figure out the gradient. So from my graph, if I see, these are the 2 values of the 2 points, and if you do your calculation, so m is equal to y2 minus y1, which is 1.1 minus 0.5 divided by 3.4 minus 1.5, and if you simplify this, m is equal to 315.78 meter second inverse. So I'm giving you this m is a gradient, and that is the velocity is 315.78 meter second inverse. Part E, suggest a reason why your calculated value for V may differ from the accepted value for V, because the velocity of sound depends on, number 1, medium, and the most important thing is the temperature. So temperature might be different, and there might be some error in calculation of the air column. So that's why we can have a different value than the accepted values. And of course, there might be a parallax error in the measuring length. Thank you very much for this video. Have a nice time. See you next time in the next video.